Welcome. Chapter 9 of Managing State and Information Security in JavaScript. So let's hop right into it. Alright, so the two things we're going to go over today, and the things that I would really like you to understand and know, is how to save state information and the objects that you can save them in, such as query strings, hidden form fields, and cookies, as well as some security practices that we can employ to mitigate security issues within JavaScript. We're going to talk a lot about that. There's issues that you'll run into when we're developing in JavaScript that allow us to create situations where security hazards can occur. We want to try to mitigate that as much as possible. So let's go. All right, so what's state information? State information is information about individual sites to a website. That's pretty much what it is in a nutshell. Now, understand that HTTP as a protocol is stateless, meaning that there's no persistent data about site visits stored in HTTP, meaning that the network protocol HTTP, the web dev protocol HTTP, however you want to look at it, it doesn't save information. It is merely used for parsing information back and forth. And how you get to the lower, levels of what that means, that's up to you. I've done networking a long time ago. I'm not going to feign to have the in-depth knowledge of what it is today. I know what it was 10 years ago. I can't tell you what it is today. Now, there's a couple of reasons for maintaining state information. The most important reason for maintaining state information is to create a identity of you. So to understand what you like, what you don't like, what you might want to like, what you might not want to like, and create trends and analysis based on that. Basically marketing. I know this says other things, but for the most part, state information is used to track what you do and to figure out what you might want to do after that. Now, I know some people might say, well, it's malicious. The FBI and the CIA, the NSA, and all these other individuals, the Russians. Listen, that's not what I'm saying. What I'm saying is that I would posit that 98% of all state information is used for marketing. So, for instance, you go to Amazon and you buy a quilt, right? Or you buy a blanket. And then you leave Amazon feeling really happy. You're like, oh man, I can't wait for that blanket to get to my house. And you go to your favorite sports site or your favorite social media site. And guess what you see there? You see an advertisement. And what's that advertisement about? What you just bought. Now, you might be thinking to yourself, how in the world did Facebook know that I like that? Or how did Facebook even understand that I might have liked something that I was looking at? Well, the reason why is because your state information on the sites that you have visited is saved inherently at the server level. And that information is more than likely shared by trusted domains, or the information is stored outside of the cookie or the web storage in another fashion. Just understand that what you have done is given them an idea of your thoughts. And that information is stored in state. And then we as developers can pull that information from the state and kind of find out, well, okay, this person really likes the Miami Heat. So I'm going to start advertising Miami Heat tickets, Miami Heat games. I'll advertise Miami Heat merch to them and kind of increase sales that way. It's actually a very profitable way to advertise to individuals, because then you're not just spamming people with information. You're actually narrowing down the amount of individuals or the people that are more interested in your stuff and trying to get them to spend more. So I understand the conspiracy theories out there about this and that, but I will tell you that majority of the state information that's used is mainly used by businesses. So let's keep that into perspective when you start thinking about all the stuff the media is throwing at you every single day. All right, let's keep going. So the first way we can save state information is through query strings. Now, query strings set the name-value pair of a state information, and then it appends that information to the end of the URL. Now, how do we know that? Well, we know that because if you look at a URL, the question mark in the URL is where the query string name value pair or key value pair, I will say key value pair a lot because that's what we call it in the real world. The key value pair is, for the most part, what we need. So you'll have jsfiddle.net and then question mark and then whatever the value is that I want to pass to the browser. Now, I'll show you what I mean by that. So let's go to my favorite API that I use for testing development, Hacker News. I goofed there. I didn't want to do that just yet. All right, so Hacker News is an API, and it's a REST API that comes from Firebase. What they did was they went out and they pulled all the articles that they can find on the net, and then they ranked them based on, how how many people have read it, how many people have liked it, whatever the case may be. Either way, it's a really nice way of trying to learn REST and JSON and JavaScript or C# or whatever the case may be. So let's talk a little more about this. If you go deeper into this, I'm just going to take this link right here that I clicked by accident when I began. hackernews.firebaseio.com is the URL to the database. Now, if I try to get to that database, as I just did, and stopped because I didn't want it to actually finish, I can't get to this database. The database is actually locked. I have no permissions to it. I can pull information from it using REST, but I can't access the tables of the database. Now, if I wanted to access parts of the database or aspects of this database, what I would need to do is understand the URL for REST. The URL for REST is as follows. This. Now, I'm going to use the entire URL and erase part of it. So, if you look at this URL, after the question mark, look at the URL. After this question mark, what do you have? You have question mark print equals pretty. Now, what does that do? Well, we'll find out in a second. I'm going to erase that and show you what this actually looks like. It's a JSON call. It's nothing but a hash table that has key value pairs associated with it. Can you read that? Probably, but it's not easy to read. The readability is very poor. So what the developers did is they made it readable by adding a query string, print equals pretty. And all of a sudden, oh my goodness, it is easier to read, easier to understand. It's like I put glasses on. Well, what print equals pretty does, I don't know. But what I do know is that that name value pair, that key value pair, changes the dynamics of this JSON call so I can read it better. It doesn't change the JSON call at all. The hash table is still the hash table. But what it did do is it changed the page based on what was in the URL. Now I can posit that there's probably a script call at the end in this page or behind the page that's looking at the URL and checking to see if there's a question mark. And if there is a question mark, then what it's doing is it's truncating the URL at that question mark and taking everything on the right side of the question mark, then using a split at the equal sign to take the name and the value, or the key and the value, and then trying to apply that in the code. So let's go back to our text. The query string, it consists of a single text string that contains one or more pieces of information. Now, you're probably asking, well, okay, well, that's only one thing. Can I add one more thing to the key value pair? Well, of course you can. You can add more than one key value pair to your URL. As a matter of fact, if I did this and said username equals Frankie, boom. Now I have two key value pairs associated with my query string. And I can ampersand do that over and over and over and over and over again. And what that essentially does is when the page loads, it looks at the URL and says to itself, is there something here? If it is, then I'm going to use it to either filter, I'll use it to format, I'll use it to go back and get other information. So it is a little more than you would believe it to be when you were looking at it. But this in of itself is how query strings work. Let's flip back. So this passes information from one page to another. We just said that. And I'm going to turn on my pen so I can draw. Passing data with a query string has its ups and downs. So it's the fastest way to do it, but it's plain text. Obviously, you can see in this example that we see print equals pretty. We see username equals Frankie. These two things are good when the information is benign. But let's say we're trying to pass PII. What's PII? Personally identifiable information. It's information that can identify you as who you are. So, for instance, your last name is PII, your address is PII, your date of birth is PII, your social security number is PII, your account number is PII, the amount of kids you have is PII, the name of your dog is PII, the name of your wife is PII. All that is personally identifiable information that can be traced back to you and create an identity of you. That's the whole point of state information, right? Well, the problem here is that the 2% that I didn't talk about, the 2% of individuals that are out there trying to make an identity of you so they can either steal it, use it, manipulate it, we want to try to mitigate the ability for them to take your PII as much as possible. So, because query strings are plain text and they're easily viewable, let's not put PII there. So, what should you not put in the query string? Date of birth, social security number, even the last four is bad. Address. Try to keep names anonymous, first initial of the first name, last name, and try to truncate even that. Keep it as small as possible. And if you even if that's not possible, then here's the best case scenario. Don't use query strings when PII is available to you when your program or your JavaScript, whether that's C#, Java, or whatever, because you can use query strings in any language, all right? Don't use query strings if you know there's PII that is going to be exposed external to your domain. What do I mean by that? If your program is touching the internet in any way whatsoever, Do not at all use query strings if PII will be exposed. That even goes as far as to say, like, let's say you built an internal portal, and that internal portal is using query strings. If the box the person is using, if the client machine is connected to the internet by proxy, your program is connected to the internet. I know some people say, well, that's not true because it might be inside the DMZ or... Stop. No. If the box is connected to the internet, whether that's the client or the server, that program is connected to the internet in some way, shape, form, or fashion. Even if there's a firewall to the firewall to the firewall. So just be careful. Query strings are amazing when you're passing IDs, non-benign information, okay? But employee IDs, probably intellectual property, and something that your company does not want to expose outside of their organization. So don't pass them using query strings. But let's go a step further. How powerful can query strings really be? Okay, let's look at that. So we talked about the question mark, check. We talked about the ampersand, check. So, and we talked about the concatenation using the ampersand of multiple name value pairs, and that's the power of query strings. Being able to pass information without having to access a cookie, access a web storage, it is very powerful, very fast, very easy to use. So, how does the query string pass? Well, what happens is that we use window.location to pull the query string from the URL. So if I switch over and I go to JSFiddle and I say alert, I just want to make sure I'm doing this right, window.location, and I run it, I should get the URL. Now, if I wanted to take a piece of that URL, all I have to do is do a substring or an index of, or in my case, I use splits. I split a lot. Split to the split to the split. It's easier that way. And in this case, there is no query string, but if I added one, I could. I can't because this is not my domain or my website. But it would pass the query string assigned to the target web page location object search property. So window.location will give you your URI. And then what you can do is you can manipulate that any way you see fit. So at this point, let's say I wanted to truncate window.location at the forward slashes, okay? So let me run this one more time just to make sure. Okay, HTTPS is in it, so I'll have 1, 2, 3, 4. I'll have 4, okay. So, let's say var split, sRay equals window.location.split, not splint or spint. And then if I said sRay, what will I get? Run. I get absolutely nothing. That's funny. Oh, I didn't, okay, I see what's going on. I can't do that. Oh, I didn't split it at anything. Oh, that's why. Okay. I'm smart guy. Array dot split at the forward slash. I messed up. I did dot split and I didn't say what I wanted to split. You have to give it the character you want to split at. Is it gonna work? Nope. Didn't think so. All right. Just wanted to make sure I was right when I said that I did that wrong. So I did that wrong. So let's do that. And let's do this. Names, words, thinking, URL equals window.location, and then I say URL.split, and then run. Nope, not Malorganite. Go back. Ah! I did it to myself. Oh, it hurts. All right, it hurts. All right, one more time. Let's URL equals document dot location. So we have the location. URL equals URL dot split at the forward slash, please. And then I want you to alert me of the URL. Thank you. Have a nice day. Run. Doesn't work. Why not? Why not? What if I said? What if I said console? Let's do this. Console.log URL and run. URL.split is not a function, but it is. But it is a function. That means that URL has nothing in it. Huh? That's weird. That's not correct, unless it's a string. Yeah, it's a string, or it's not a string. It's something else. All right. Oh, I didn't do that right. Okay. So URL is not. That's the answer right there. Run. Got it. So, when I did document.location to URL, I didn't just get the URL. What I got was what I was given was a hash table. So what I did there was I debugged it to see what was inside URL. And when I saw that it was the hash table, I just checked for href, and then I used that. I could also use host, and that would break it down even further. So at this point, I wouldn't need to do it at that part. I can do it at this part. Run, and there you go. Fiddle JShow net. And what I did was I took the URL, I split it at the host. As a matter of fact, if I think about this correctly, I don't even need to do that. I can do this, .host, .split, and then I can get rid of that. Run. Ha! All right, so what did I just do there? So I know that you're new to JavaScript, but the one thing about JavaScript that makes it extremely powerful is that you can dot notation everything together. So I had 2 lines of code here. I had one line of code that was url.host.split, which is I want to pull the host. I'm asking for the host property or the host key. It'll give me the value of that key, and then I said split it at the period, and that's what it did. But then I thought to myself, well, hold on, I don't need to do that. I can do it all in one line. So document.location gives me the URL plus all this other stuff that comes away from the location object. Then I said I want the host property, and then I said split that host property at the period. One line. And you can do this. Your code, I know right now it's kind of like, what? But yeah, you can pretty much write maybe 3 lines of code and it does an exponential amount of activity. But either way, this is how you can pull the actual URL when you're trying to manipulate it and take parts of it. So in this case, if I wanted to pull the query string, instead of saying period, I would say question mark. And then boom, I have the question mark from the query string. All right, next. Let's go back. I'm going to update that so I don't lose it. That would be painful if I did. Oh, I didn't want to do that. Go back. There we go. All right. So in this case, the ISBN number, and ISBN is the key, the number is the value. Quantity is the key, 2 is the value. This is available as the object of the search property of the location object. So just understand that if you use document.location, you will get the URI. But you will also get a bunch of other things. So make sure that when you do document.location, you look at the properties that are inherent to the hash table that is being passed to you from the location object. Once you do that, you'll have everything that you need. So if you want the href, you'll get the HTTP as well. If you just want the name of your site, then you can use host name. And if you want to see what's inside of it, just like I said, do the document.location, save it to a variable, and then go into your console and see what that variable contains. Okay, so if you want to remove the question mark, you can use substring. There's only going to be one question mark when you do a URL that's got a query string. So you really don't have to do that. What you could do is you can say split, and then the absolute URL, which is the part of the URL that, or not the absolute, but the URL that's before the question mark will be in the 0th position, and the query string will be in the 1st position. And then you can just say first position split at blah, 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 blah. And you just keep splitting. Splitting is a very efficient way to get the value that you're looking for. Substring is nice, but it's complicated, and sometimes it doesn't work, and I'm not too fond of it. But in this case, you would do location.search, and then you would do query data substring, and then 1 being the value of 1, meaning 1 question mark, and then query data.length, which is the length of the query after the question mark. So then after that, you will convert the individual pieces of the information into an array element. Now, you will do the same thing for cookies and web storage as well, because when you pull the information, it'll be in a string. So you'll use a split method to split your data. Let me check to see if I'm recording. Split your string at the ampersands if there's multiple key value pairs. Be aware though that if there isn't an ampersand in your string and you try to do an index of or anything of that nature, what will essentially happen is you will get an error saying that the ampersand does not exist. So what you want to do is check to see if the ampersand actually exists. And if you do that, you can do that with index of. Look up, find char in string JavaScript, and it will give you a slew of functions and methods you can use. There's a ton of them. The book also has its own. Index of is the old and tried and true way of doing it. and it will find the character just fine. But before you try to do a split on any character, you want to make sure the character actually exists. And in certain situations, it might not exist. If there's an ampersand, ampersand means that there's more than one query string, and there might not be. So always check first. So hidden form field is the second way that we can do the saving of state information. Now, the one thing that I will say about hidden form fields is that I completely and utterly abhor them. And the reason why is because hidden form fields in and of themselves are the one thing that most, the 2% we talked about, the people that have malicious intent, they look for those. Okay, so the best thing you can do is not use them at all. But we're going to talk about them anyway because you can use them in certain situations. So it's a special type of form element that is not displayed by the web browser and allows information to be hidden from users, created with the input element. So input can give you text box, buttons. It can also do hidden. It temporarily stores the data sent to a server along with the rest of the form, and there's no need for the user to see that hidden data, which is why we're using the input. Now, obviously, cookies do the same thing, so I mean... All right, so this is how it works. The user completes a form. The form then encodes a query string, and it copies that information to a hidden field on the next page. The user then completes the second form, and then that is submitted with the query string, with the new query string and the encoded fields in the hidden server, or in the hidden input to the server. Now, in most situations, we don't do this anymore because, for the most part, we can use JavaScript to kind of manipulate how the page changes. And we can REST async information to a database that way, and it's fast. So this is kind of an older way of doing things, but this is how it would work if you wanted to do it this way. Query strings and hidden fields temporarily maintain state information, and that please understand that it is not persistent. So persistent means that the temporary information is stored in the computer for days or weeks. That's not true with query strings and hidden fields. They're gone. Once that session is over, it's over. Cookies are the way that we can transcend sessions. Now, cookies are very powerful, but they're also the bane of most information security professionals' existences. And the reason why is because a lot of developers don't assign expiration dates to cookies, and thus, in certain tertiary situations, I guess, it can turn into a persistent cookie, and that cookie lasts and lasts and lasts and lasts and lasts. And if there's information in that cookie that can be used maliciously, then you're putting your system and your organization and the users of that system in a compromising position. But what is a cookie? Let's talk about that before we get into the negatives and positives of it. A cookie is a unit of information, normally kilobytes in size, that contains information about the user. It's stored by a web server in text files, and it's also stored by the client machine. Remember that. It's stored at both locations, the web server and the client's machine. When the web client visits a web server, saved cookies are sent from the client to the server. Temporary cookies are available only for the current session. Now, in certain situations, if you don't give an expiration to a cookie, it will always be a temporary cookie and die after the session. What is a session? A session is the connection between your browser and the server. That is the session. Now, certain websites like JSFiddle keep sessions open indefinitely. So you'll see that I'm not really going to add an expiration to my cookie, but because I didn't close the session, it still exists. Now, I could close my tab. And I know the book says that if you close a tab, that it closes your session. Not true, not true. And I'll show you when we do it. That is not true. What happens is the session at the client level dies. Or no, the session at the server level dies, not the client level. And the client stores those cookies until the next session, regardless of whether there's an expiration date or not. The only way you can get rid of that is by closing all your browsers of that specific browser type. So, for instance, if you close a tab of your Chrome browser, that will not all the time close your session. Depends on how your system administrators at your server level are calculating time to live on certain things. If you only close a tab, there's a 9 out of 10 times chance that it won't close a session, and thus your cookie will survive. You would have to close the entire browser. This is the same with IE. So, that line right there, only available for current browser sessions. We're going to talk a little bit more about that in later pages, where it actually goes into depth about how it releases the cookie. I'm here to tell you that I've done a lot of testing on this, and the only way to get rid of a temporary cookie, is to close all your browser sessions, meaning you have to close the browser itself. So, we talked about query strings and hidden form fields. Two methods of storing state information on users' computers is cookies and web storage. So we talked about what a cookie is. We talked about temporary cookies, and we talked about how they only remain current. They only remain available during the current browser session. Now, persistent cookies are cookies that most information security professionals kind of like, I'm trying, but I can't. And the reason why is because persistent cookies are cookies that hold information for periods of time that are longer than the session. And that can be dangerous, especially if the information contained within the cookie is personally identifiable information or intellectual property of the organization for which you work. So, persistent cookies remain available beyond the current browser session, and they're stored in a text file on the client computer. The limitation of the use of cookies. So cookies are not this all omniscient, all-knowing, forever existing object. They're very small in size. They are normally a max of 20 cookies on a server or domain, or the max is 20. The total cookies per browser cannot exceed 300, and not all browsers enforce cookies. Now, in today's day and age, we're kind of migrating away from cookies to web storage, but cookies are still a mainstay of most browsers today. So, how do we use a cookie property in the document object? It's easy. Document.cookie. Boom. There it is. That's it. Now, the only part of the cookie that is integral, obligated, mandatory, must be done, or your cookie will never exist, you have to give it a name. Name your cookie. So, you can say name or username. They both pretty much do the same thing. And once you name the cookie exists until you tell it to not exist, which means that if you don't give it an expires property, as you see here, and you leave your browser open like I do overnight for days at a time, the cookies will also survive. So, if you want your cookie to die eventually, you need to give it an expires or close all your browser sessions. But the four main cookie properties that are created are expires, path, domain, and secure. Now, you can create your own properties in the cookie to save specific types of information that you want the cookie to remember. But for the most part, the four optional attributes that are inherent to the cookie property are these. And here's the slide that kind of gives you a drop of, all the attributes that are inherent. Now, the one that I want to reach out and kind of talk to you about, other than expires, is secure. So when you say secure equals true, what happens is that the cookie can't be transmitted unless it's transmitted over a secure protocol, meaning HTTPS, SSL, TLS, blah, 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 blah. So let's talk about the attributes. The name attribute is the only required parameter. It specifies cookie name value pairs or key value pairs, and the cookies created with only the name attribute are temporary cookies. So if I said username Francis into the cookie, it's a temporary cookie. The cookie property adds another entry to a list of cookies. Now notice what it says here. Cookies created with only the name attribute is a temporary cookie. If you add more information to the cookie other than your name, guess what? Or other than the name of the cookie, guess what? It's no longer a temporary cookie. This is the problem, okay, that a lot of security professionals have and wrangle with. Normally, the cookie contains more than just the name. But if you don't give it an expires, guess what? It's never going to die. So here's an example. And, I was going to do it in JS Fiddle, but it's really self-explanatory. Cookies cannot include semicolons or special characters. It can use special characters in cookies if using encoding. What is encoding? Encoding ensures that when the cookie is read, it looks like wingdings. And you'll say encode URI components or to encode it, and then decode URI components to decode it. Here it is. Encode URI component, decode URI component. All it does is it converts it to special characters in the ASCII2 value of hexadecimal. Boom. And then decode does the complete opposite. They both work the same. You call the function, and then you add your text, which will be the cookie. You call the function, add your text, which will be the cookie, blah, blah, blah. So, testing applications that use cookies. Browsers open local documents without HTTP. This is if you open a browser, or if you open a web page that's stored on your computer, which we do all the time because we're actually in a development class and we're not hosting it on a web server. So, browsers open local documents without HTTP. Some browsers don't support setting cookies when HTTP protocol is not used. Chrome does. So, can focus testing on browsers that support cookies on files opened without HTTP. A more robust option than testing on your box locally is to run it from a web server that opens things in HTTP protocol, and some editors that are built-in that have built-in testing servers like Visual Studio. So, the expires attribute we've talked a lot about, and so we'll go over it a little more. It determines how long a cookie can remain on a client system before being deleted. The cookies created without this attribute are available to the current browser session only. That is not true. We talked about that already, and the truth is that if you give it a name and any other attribute, it will remain a persistent cookie until you decide it's not a persistent cookie anymore. And in order to give it an expiration, what you have to just do is say expires, and then the date you want it to expire at. The date needs to be in UTC form. So if you want your date to be of a value that JavaScript's going to understand, 2UTC string is imperative. I'll go a step further, actually. If you want to delete a cookie, you need to add an expiration, or if an expiration does exist, you need to make that expires date yesterday or the day before, any date before today, and that will expire the cookie. I will say that again. If you would like to delete or expire a cookie, you have to change the expires attribute to a date, UTC string, that is older than the day we are currently in. So normally 7 days from today, or 7 days ago, and then it'll die. There's no way you can go in and say delete cookie. It doesn't work that way. You have to change the expires date. Okay. You can manually type a string in UTC format. I would preface you not doing that. I would just say to UTC string and be done with it. So when you do new date, let's go over this for a second. So let's erase this, and let's say var date let date equals new date. What does it look like? So we'll say alert date. Run. We get a date. Now, this date is, I believe, Eastern Standard Time. Yep. But it's not UTC. UTC, I think, is Greenwich time. So if I wanted to make this UTC, what I need to do is this. Dot notation, remember? I got a totally different date. This is the time that that JavaScript understands the best. Computers use Greenwich time. So UTC time. And the way to get UTC time is all you have to do is when you do new date, just say to UTC string. You can even do this after the fact. You don't have to do this here. I just did it there because I didn't want to write date again. But let's say you're doing some date manipulations and then you want to do it. You can do to UTC string on any date object that you have. So, just an FYI. All right, let's go. Configuring availability of cookies to other web pages on the server, you want to use the path attribute. So if you want to make a cookie available to other web servers, you'll use the path attribute to make it available to either some web servers or all web servers, or web pages, I'm sorry. So the cookie available to all web pages in the same directory, that's a default. To make the cookie available to all directories on the server, you would use a slash. So basically you would say the following. Let's screw it back over. And instead of this, I would say document.cookie equals name equals Francis, and then path equals /. That is how you would make it available to all directories on the server. If you just wanted to make it available to all web pages in the same directory or website, you don't have to do this. You can just say name equals Frankie, or name equals whatever you want to equal. All right. Var username. Wait, I'm reading the wrong thing. Cookies from other programs stored in the same directory can cause JavaScript programs to run erratically. Never ran into that, but it's possible. Sharing cookies across a domain. You use a domain attribute to notify your directory, your web server, that you need this cookie to be used across the domain which you are using. What is a domain? We talked about that. Windows.location will tell you your domain. It is the URL, your absolute URL of your website. And please understand that you cannot share your cookies outside of your domain. So that goes back to your question of how does Amazon share its information with Google? There are other ways. Okay, so the secure attribute we talked about, we'll go over it just a little more. It indicates the cookie can be only transmitted across a secure internet connection. HTTPS, SSL, TLS, If it's HTTP, it will not send. It will just go, oh, nope. So, parsing a cookie. Parsing means decoding or re-encoding or whatever. So, decoding it using decode URI component, use a string object to extract the individual key value pairs, and it's similar to parsing query strings. You do not need to remove a question mark because it doesn't exist in the cookie, and ampersands are replaced by semicolons. So, and this is an example that they're using. They create 3 encoded cookies. They then read them with the cookie property and decode them. They then split them to copy each key value pair to the cookie array. And then they use a for loop to loop through the array elements. And if the statement to check the name portion of each name and value pair is true, then they have the value that they want. So here we go. It has the document.cookie. It loads it with the username. It then encodes that username. Document.cookie. It loads it with the encoded member name. It then does it again. These are 3 separate encoded cookies. They're not one and the same. They're 3 separate cookies. So document.cookie, audio equals, and then it encodes the audio and then loads it into the cookie. So there's 3 cookies. Username equals whatever that username is. Member equals whatever that member name is. And audio equals whatever that audio value is. And they're all encoded. So when you pull that back, you need to decode it. Because if you do not, it'll look like a bunch of gibberish. So decode URI component, you can decode the entire cookie. You don't have to go one by one to decode. And then what they're doing is they're splitting the cookie at the colon. Why are they doing that? The reason why is because all the cookies are separated by a colon. So when you separate it at the colon, you get the cookies in their nice respective array positions. So username is in array position 0, member is in array position 1, audio is in array position 2. Then what they're doing is they're initializing a variable called current username, and they're trying to find the username, right? So what they do is they loop through the cookie array looking for the current username. If the current username.substring equals index of whatever the username should be, then stop the function and do some stuffs. If not, keep iterating through the cookies until you get the right one. So, cookies, in order to delete a cookie, we talked about this, we'll speak about it again. If you want to delete a cookie, you have to change the expiration date to a date in the past. It's not intuitive. It doesn't know that, oh, I need to get rid of this. It only will know that when you say, oh, wait, the date was yesterday. And it goes, oh, it was? Okay, well, I thought it was today. Okay, I'm sorry. And this is what they did here. They changed expires to get date -7. So they pushed the date back 7 days, and they were able to delete the cookie. Persistent cookies can interfere with testing because persistent cookies are a pain. A good idea is to delete cookies periodically, and you can do that using delete history, delete browsing history, clear recent history, and clear browsing data. Those are respective to their browsers. Common uses of cookies never originally planned. We talked about that. Marketing was not one of the strategies of cookies. Cookies were to give persistent customization to web pages for users, but it's kind of graduated into something a little more, which is not bad. It can be used maliciously, but it's not bad. So, web storage is not supported by older browsers yet, or ever, but as we move forward into the 21st century, you will find that older browsers become obsolete, or older things become obsolete, so not a big deal. Cookies are still the standard, but web storage offers additional features, both practically and security facing. So there's 2 types of window storage properties in the window object. There's window.location storage, which remains until you run the code. It remains until you run code to delete it. It's similar to persistent cookies. And then you have session storage, which is removed automatically when your user closes the browser tab or window. Now, I haven't tested to see whether web storage actually closes or deletes itself or removes itself when the tab is closed, but I would assume that it does. And here's an example. You can also store other keys in your cookies as well, or in your web storage as well. So in this case, they're storing a new value called fname. And then they're pulling the first name that was typed into the page. And here are the methods that are associated with web storage. Notice that there was no clear when we did cookies. You had to change the expiration date to the date in the past. With web storage, you can just say clear, and it removes all the data. So let's get to the juicy part, right? Security. So a lot of people go down the road of, well, we just need to lock it all down, do the whole Gandalf, you shall not pass. That doesn't really work, because when you start doing that, then what you're doing is you're making the user experience so cumbersome that they're not even going to want to use your product. This is what happened, about 10 years ago with a lot of the web paradigms that we were employing. There were so many security features that were inherent that it made it clunky and cumbersome for the developers and clunky and cumbersome for the users, and they made a lot of gobbledygook to step through. And so what essentially happened was it made it easier for you to compromise the system. So yeah, no, not good. Consider web server security and secure coding issues. I don't like the word secure next to coding. Defensive coding, I am all about it. Secure coding, that you can never secure. There's the code is not, you cannot objectify code. You cannot add an adjective to code and say that is what it is. That is not true. People can be malicious. People can be secure. Code cannot. You can defensively code. You can offensively code. You cannot secure code. And I want to drive that home, because secure coding means that there is code out there that you should write and code out there that you shouldn't write. That's not true. There are ways that you should write your code. So, with that being said, I will get off my hook. I will tell you this. When you code, always take into consideration the things that you're parsing. That's it. The data is what we need to secure. The coding practices are irrelevant. It's how we're getting the data secure. Remember what we talked about earlier in the chapter? You can put PII and query strings, but if it's connected to the internet, that's completely utterly asinine, right? Yeah, you probably will think, well, what about the users that are using the system? They can see it. You trust them enough to hire them, right? HR knows everything about you already. So now they know your social security number. They already knew your social security number. It was not a big deal. So, and I'm being facetious, but understand that secure coding is a catch business phrase. It's defensive coding. Coding to ensure that your code doesn't present any security flaws, issues, or bugs that can be exploited. That's it. Secure coding means that there's specific lines of code that you shouldn't write it ever, and there's other lines of code that you can write because it's okay. No, that's just no. So, web server security technologies, firewalls, SSL really help us to secure our information and encode. Firewalls block unnecessary activity. SSL encodes and makes sure the data is not easily manipulated. JavaScript programs downloaded and execute locally cannot operate at the computer level, which means that if you run a JavaScript program, it will only work in the browser. It cannot manipulate computer objects at the WIMI level, at the iOS level. It cannot manipulate anything at the mobile application level, iPad level, Unix level. It can only manipulate what's in the browser. So JavaScript by itself is actually very secure. It is just the little things that can make it very not well defended. So I'm just going to cross that out. Defensive coding is writing code to minimize any intentional or accidental security issues. And that is literally it. All code is insecure unless proven otherwise. I guess that's a true statement. No magic formula for writing secure code. This is why I don't like that phrase. Because it can be manipulated to mean anything. And if somebody doesn't like JavaScript and they're a security professional, they can say, well, JavaScript is very unsecure, so we're not going to use it. But that's not true. It is actually one of the more secure languages you can use because it only operates in the browser. How is it unsecure? Please be more specific, good sir. Well, I just read it in a book. Okay. Well, as a developer, I will tell you that the JavaScript only operates at the browser level and cannot be manipulated any other way. So please tell me how. And I know I'm being I'm getting amped up about it because I've had these conversations that are just, they get to the point where you just sit there and go, I agree, disagree. I can't go down this road with you because I know I do it for a living. But right, there is no magic formula. The formula isn't to write secure code. The formula is to defensively code and understand the information that is being passed through your code. That is what's imperative. So, security areas of concern are protection of the web page and JavaScript program against malicious tampering. Of course, because it's in the browser, it is susceptible to a lot of attacks. Privacy of the individual client information, we talked about PII. Protection of the local file system of the client. Well, okay, and this is something that is true but not true. JavaScript can access the local file system, but it cannot manipulate local file objects at the WIMI level. And what I mean by that is it can't change your GAC. It can't do reg edits. It can't do operations or scheduling or anything of that nature at the computer level. It can only take a file. So if you have your files in a secure location, not a big deal. So what's a code injection attack? A program or user enters JavaScript code that changes the function of the web page. This is why I said that writing your code directly in the page is not best practice. You want to move that somewhere else into a page that validates the form to help prevent those things from occurring and escaping characters in your code to ensure that what you wrote is what you want. So, another security concern is privacy of individual client information in the web browser. We talked about that as well. One important security feature is that it lacks certain types of functionality. It can't manipulate files. It can't create a network connection. It can't do anything at the computer level. So they can name things all day long. It's just it cannot manipulate anything at your computer, period. It can't add a printer. It can't add a scanner. It can't do any of that stuff. It can't close a port. It can't open a port. It can't turn on your Windows firewall. It can't do anything at the computer level at all. So it restricts how JavaScript code, the same origin policy restricts how JavaScript code is accessed between Windows tabs and frames. To view and modify elements in other windows and frames, they must have the same protocol and exist on the same web server. This is the whole domain idea, right? You can't go between domains. The reason why is because if you could, it would be very easy to be for your domain to be compromised if you're using JavaScript. And it applies to the domain name and the server on which the document is located. So, the same origin policy prevents malicious scripts from modifying blah, 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 theft of private information, and the policy protects integrity of the web page design. Just know you can't move between domains. That makes it easier because at that point, like I said, individuals of ill repute who would like to invite malicious or have malicious intent to your code can't manipulate it. So, the domain is a part of the document object, and if you wrote document.domain, you would get the root domain. You can change it. You could change the origin of a document to its root domain name by changing the domain property. And this allows documents from different origins in the same domain to access each other's elements and properties. So, sometimes you want to run scripts from other domains. CDN, Google, jQuery, blah, blah, blah. I do it all the time. At the end of the day, if you want to enable the third-party script, just add the script to your page. That's it. And then that would essentially be the exception to the same origin policy. Or if your system administrators and firewall guys are having a conniption, you have them, look at it and say it's good to go, and then they can add the exception at the network level. So summary. That was fast, wasn't it? We talked about state information. State information is information about individual visits to a website and everything that happens in that visit. HTTP was designed to be stateless, not to contain information. But that changed over time with businesses wanting to understand you more, understand you better. Most common tools for maintaining state information are query strings, which are not used as much as you may think they are, hidden form fields, which are taboo, cookies, which is the standard, and web storage, which is the way we want to go. Query strings set a key value pair appended to the target URL that is concatenated using a question mark. You can hide information from users in a hidden form field. Cookies are small pieces of information about a user that are stored by a web server and the client, can be persistent or temporary. The cookie property with a required name is the only required attribute in a cookie property is the name. You can use special characters in cookies if using encoding, and if you want to encode, you use the method encode URI component. If you want to decode, you use the decode URI component to decode it back from the ASCII to gobbledygook. Cookies are one continuous string that must be parsed, so when you pull the cookie, you have to break it down into its many different pieces. So if you want the cookie to be in their own little position, you would have to break it at the split the cookie at the semicolon and then at the equal sign. Web storage are similar to cookies but offer more features, but are not as widely supported as cookies are. Secure coding or defensive coding, yeah. Writing code to minimize any intentional or accidental security issues. Defensive coding I like because it doesn't objectify coding. It just tells you what you need to do. It's like defensive driving, right? Defensive driving doesn't objectify driving. It implies that the driver is a person who needs to be defensive, right? So when we say defensive coding, we're implying that the developer is the person who needs to defensively code, not that the code itself is a defense. No, that's benign, or that's asinine. Either way, I believe this is the last slide. Ba-boom. That's it. 5th time's the charm. I've recorded this 5 times, so you can see I'm I'm ready for it to be over. Either way, I hope that this class or this chapter really shed some light on some things that were a little more confusing beforehand. Remember, it's just JavaScript. It's not that. It's just tedious. It's not as hard as you think it is. All in your head. So, text me, chat me, email me, let me know if you need help, and I'll be here. Either way, I hope this helped you out. You guys have a good one. Ciao.